In the last video, we discussed the concept of higher order derivatives. Now we're going to just take a look at the notation. Okay. So if I have y equals f of x, I can take the first derivative. And we said we can call that y prime. We can call that f prime of x. We can call that dy by dx. We can call that df by dx. And we can call that d by dx of f of x. Now we also saw that we have this df of x. This notation, the book does not show us how that generalizes to higher order derivatives. So I'm just going to work with these more common types of notation and show you how they expand to higher order derivatives. Okay, so we do have this notation, and sometimes it has a subscript of an x here, okay, for first derivatives, but we're not going to extend that to second and third derivatives. It's just not given in the book, and this notation isn't as common. Okay. If I go to a second derivative, well, that's just y prime, double prime. That's f double prime of x. Now with this differential notation is what we call this. What we're doing if we take the second derivative is we're taking the derivative of the derivative. So I'm just going to work that out here. I'm taking the derivative. That's the derivative operator that tells me to take the derivative of whatever comes after it. But what I'm taking the derivative of is dy by dx. So if I just read across on top, it's d dy. If I read across on bottom, it's dx dx. Now, this is not a multiplication problem. This is applying this operator, which tells me to do this thing, calculate the derivative. I'm applying that to this function. But I'm going to borrow some notation from algebra. If this were multiplication and I had dd, I would write that as d squared y. And then I've got dx dx. I'm going to write that as dx squared. Now, the algebra teacher in me is appalled because, of course, exponents only act on what's immediately next to them. So shouldn't that mean dxx? We're squaring the x but not the d. Well, this is metaphorical notation. We're letting it be understood that the d and the x here can't be separated. So that this is applying to two copies of dx. So it's dx dx. Okay. Now, it looks a little bit strange because on top, the thing that looks like an exponent comes after the d, on bottom it comes after the x. If you recognize where it comes from, I'm taking the derivative of the derivative. You can see d dy, two d's and a y. Dx dx, two dx's. Okay. Same thing here. This would be d squared f by dx squared. And here we just adjust the operator. It becomes the second derivative operator applied to f of x. Because what we did is we started with f of x. We took the derivative of that, and then we took the derivative of that again. dd is the d squared, dx dx is the dx squared. Takes a little while to get used to this notation, but there is a method to the madness. Okay. Now, if I want the third derivative, it's y triple prime, it's f triple prime of x, it's d cubed y by dx cubed, d cubed f by dx cubed, d cubed by dx cubed applied to f of x. Okay, all of that works nicely. Okay. If I want to take the fourth derivative or higher, but let's just write out the fourth. Okay. At some point, this prime notation is going to become horrible. Let's say I'm taking the 20th derivative. I do not want to write y 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I do not want to write 20 prime signs, nor do I want my reader to have to count them to know which function I'm talking about. So it's reasonable to have up to 3 tick marks using this prime notation. Once we get higher than that, what we do is we put it in the exponent position, but in parentheses. Those parentheses are super, super important, because if I didn't have those parentheses, this would be the 4th power of y. With the parentheses, it's the 4th derivative of y. So this would be f not to the 4th. Those parentheses tell me it's the 4th derivative of x. And of course, here, I can just say this is d to the 4th y by dx to the 4th, and just change the things in the exponent position to be whatever derivative I'm taking. So the change here is just in the prime notation. For the first 3, we just add another prime each time we take the derivative. Once we get to the 4th or higher, we put in the exponent position the order of the derivative that we're calculating.